Hi, I'm Mr. Parker and this is question 1 on the OCR Mechanics 1 paper from January 2009. For more questions on this exam paper, click the link here or check in the video description. In question 1, we have a particle P of mass 0.5 kilograms, which is travelling with a speed of 6 meters per second on a smooth horizontal plane towards a stationary particle Q of mass m kilograms. So that's all given in the diagram. And the question says the particles collide, and immediately after the collision, P has a speed of 0.8 meters per second and Q has a speed of 4 meters per second. In part 1, it says given that both particles are moving in the same direction after the collision, calculate m. The first thing I'm going to do is label this diagram before, because up here is what happens before the collision. I'm also going to put the particle Q is stationary, so that's travelling at 0 meters per second. I'm interested in what happens after the collision as well, so I'll draw a diagram for that. And it says both particles are moving in the same direction. Well, if P is moving to the right and Q is stationary, then the net momentum after they collide is also going to have to be towards the right. So we're going to have P, and that's going to be moving to the right with speed 0.8 meters per second. And it's got a mass of 0.5 kilograms, that hasn't changed. And we're going to have Q, which is also moving to the right with a speed of 4 meters per second. And that has a mass of m kilograms, which we don't know yet. So the only piece of information that we don't know in the whole question is the mass of particle Q. To find m, we're going to write down a momentum equation, and that says that the momentum before the collision of the whole system has to be equal to the momentum of the whole system after the collision. So remember, the momentum for each particle is mass times velocity, so we'll do that for particle P. So we're going to have the momentum of P is 6 times 0.5. The momentum of Q is 0 because mass times velocity here will give us 0, so we won't put anything for that. And on the right hand side we'll write the momentum after, so the momentum of P is 0.8 times 0.5, and the momentum of Q is 4 times m, which we'll write as 4m. So let's simplify everything. 6 times 0.5, that's a half of 6, which is 3. 0.8 times 0.5, half of 0.8 is 0.4, and we'll leave the plus 4m as it is. Let's subtract 0.4 from both sides. We get 2.6 equals 4m. So to get m, I need to do 2.6 divided by 4, which is 0.65. So the mass of particle Q is 0.65. In part 2, it says given instead that the particles are moving in opposite directions after the collision, calculate m. Now in part 2, we're going to use the same diagram for the situation before the collision. After the collision will be different to what we have here though, so we're going to redraw our diagram for this bit. So the speed of the particles hasn't changed, but the speed doesn't tell us what direction something's travelling in. So this time, instead of P moving to the right with a speed of 0.8, we are going to put P moving to the left with a speed of 0.8 meters per second. Q is still going to move to the right with a speed of 4 meters per second, and the mass of P will still be 0.5 kilograms, and we'll call the mass of Q m kilograms. But this time m will be different to what it was in part 1. So let's write down our conservation of momentum equation again. Remember, the situation before the collision hasn't changed, so that's still going to be 6 times 0.5. The momentum after though will be slightly different. In part 1, all of these quantities here were positive, and that's because everything was travelling to the right. This time particle P is travelling to the left, so we are going to write its velocity as minus 0.8. So the momentum of particle P is going to be 0.5, the mass, times minus 0.8 to reflect that it's moving to the left, plus 4 lots of m, because particle Q is still moving to the right. So let's simplify everything. We get 3 on this side. 0.5 times minus 0.8 is minus 0.4, and we still have the plus 4m. This time we're going to add 0.4 to both sides, so we get 3.4 equals 4m. So to get m, I'm going to do 3.4 divided by 4, which gives me 0.85 kilograms. So for part 2, the mass of Q is 0.85.